Welcome to the final Matlab tutorial. In this tutorial, we'll finally automate Where's Wally. We'll perform the template matching operation we learned about in the last two tutorials, and we'll also return several mugshots so we can easily see which one is really Wally. In this tutorial, we see everything come together. We're going to use all our knowledge from the first 7 tutorials to automate finding Wally. So let's move over to Matlab and get started. In this tutorial, we're going to be completing Where's Wally? And as you can see, there's no code template provided because in this tutorial, we're going to see everything that we've learned come together. So we'll start as always by clearing the workspace and the console, and we'll set up our default access label sizes. We can go back to tutorial 1 to see how to do this if we forget. Let's put this in. There. Next one we want to do is default access label font size, and we'll make this 18 on that. Okay. Now again, from tutorial 1, we can use what we learnt there to read in the 2 images we need. So the first image we want to read in is the crowd image of Where's Wally. So let's call that Wally crowd. We'll use im read to read it in. And here we'll use tab to auto-complete that, which I haven't used much, but it's very useful. Again, use tab. Okay, let's just do a 1x2 subplot, and we'll plot both the input image and the template. So just open up a new figure, figure 1, and we'll clear it. And we want to do a subplot. We want that to be 1x2, and we want to edit the first one. And we'll use im show, and we'll plot the Wally crowd. And let's do a title call it Wally crowd. X label, well, it's an image, so it's going to be labeled U, and its units are pixels. We'll do a Y label as well. It's called V, its units are pixels. Alright, how do we go? Okay, and we want to do the same thing in the second subplot. Oh, before I forget, we want to turn on the axis. Those axis numbers will be useful for finding Wally. Just grab this bit. Now we want to access the second subplot now. And we want to show the Wally template. There we go. So now we just need to do our template matching operation. And that will just use our image filter function. And if you remember, there's 3 things we need for this. First we need the input image, which is Wally crowd. And then we need the template, which is Wally template. And we need to tell this what metric we'd like to use. And we'll use the only one we have, ZNCC. Now this should still work. There's one thing that we forgot to do in the previous tutorials when we wrote this function. And we're only seeing this error now because we're using real data. So if we just go to image filter, the first thing we did in this function was convert the input image to a double. You need to go back and do the same thing for the template, convert the template to a double as well. So that's run, and we've got an output. Well, let's plot it. Figure 2, clear the figure. We won't use im show, we'll use image sc, which, remember, plots a matrix as if it was an image but scales the colors. I'll give this an X label and a Y label. You know what? We'll just copy this from up there. Except this is going to be... Okay. We'll also plot a color bar so that we can see what each of these colors means. Okay, well, now we've got everything we need to find Wally. We've produced the similarity image. We just need to interpret that data. So what if we sort it into descending order? So the first few elements are the most likely ones. So if we don't remember how to use sort, we can always just use help sort. Now, if you remember from a previous tutorial, sort always works across the rows or down the columns. So there's no way to make it sort the whole matrix unless we convert the matrix into a vector. And the way we do that is by putting a colon in brackets. So remember, just briefly, if we have rand 555, now that's a matrix, but if we do this, it'll stack the columns on top of each other. Okay, now if we run that, we get a sorted version of similarity and the indices of those values. And we can see it's in descending order. Okay, well, let's create a new figure again. We've got a lot of plotting to do. First thing we'll do is we'll plot the original Wally image again. Yep, we'll plot the original Wally image. And now we'll take this image and we'll just put circles over the three most likely characters. So we'll use a for loop since we're going to do this several times. For I equals 1 up to 3. So we just want to convert a few of these indices to sub-indices so that we can get an X and Y coordinate for a circle. And we just want to plot the circle. And we won't call that Wally crowd. I'm going to call this Wally found. And we need to put a hold on here, or we'll just replace it with the plot of a circle. So we're going to use YC, XC, we'll use our ind to sub function, which will convert these to sub indices. So I'm going to give it the size of the matrix we're after, which is similarity. And we're going to give it the index we're dealing with, which in this case is the first value, and then the second value, and then the third value. Okay, so that should get us the center of our circle. And then we just want to use create circle, which we give an X center, a Y center, and we give it a circle radius. Now our template is 25 pixels high and 21 pixels wide. Let's just arbitrarily choose 20 pixels for the radius of our circles. And now we just need to plot our circles. And let's plot them in red. Now if everything has gone to plan, when we hit run now, we should have found Wally. So let's give it a go. Well, there's 3 circles there. It looks like this one's probably Wally. What we can do is let's create another figure that's got 3 close-ups, 3 mug shots, so we can see which one's really Wally. So we'll do a subplot, do a 1/3 subplot, and actually, let's do this in a for loop. So each time we go around the for loop, we'll be accessing the ith plot. Now, what we want to do is we just want to zoom in on an area of that image and just pluck it out. So this is like indexing a submatrix like we did when we made the image filter function. So let's call it temp image. And we're going to grab it from the Wally crowd image. Now we need the X center and the Y center. So let's just copy this again. We should be able to reuse that little piece of code there. So we just want to get the patch of the image that's centered around the X center and Y center, but we want to grab an area around that. So let's do the same trick we did when we wrote image filter. So we'll just grab 15 pixels either side and top and bottom. We need another bracket there. So what we should have done here is created a little image which is 31 pixels by 31 pixels. And now let's plot this using imshow. And we'll need to give each one of these little axes a label. And I think we'll also give it a title. And as a title, why don't we use the similarity score so that we can see how highly each one scored. Now we've used fprintf before, but this time we're going to use sprintf. So when you use fprintf to write something like hello, that prints to the console. But if we use sprintf, it saves it as a variable. And then we can do other things with it, like put it in the title of a plot. And let's use a 4 decimal point floating point number. We can use the sorted version of the similarity matrix here. Let's see if that worked. Great. Well, it looks like the first one's Wally. And the other thing we'll do, make sure all these images are an appropriate size because we're about to export them. So to export these to file, which we did in the first tutorial, we'll use save as. To use save as, we give it the number of the figure. Let's call the first one input, and let's save it as a PNG. And we're going to do this for 4 figures. The second one is our similarity. The third one is our Wally found image. The last one is our mugshots. Now here I'm just pressing the keyboard shortcut for run section. So that'll just run this section of code that the cursor's in. That brings us to the end of this Matlab tutorial series. We really hope that you've gained something from doing these tutorials and that you're now able to use MATLAB to solve a variety of engineering problems.